the one is for the one sample, the other one is for the other sample. Okay. So at 2 minutes, you do take a value here and take a value there.
Okay.
And you take the average.
And then put it in mix one.
Mix one.
So mix one is actually 2 samples.
Yes.
Average of 2. Okay.
Yes. And then, but okay, don't use mix one. Mix one is, use that as a reference to compare your material with my material. This mix one is what I got the other day. Okay? Use mix two, for instance, for your material, right? And then you can see, okay, are you behind, are you ahead, whatever is going on, right?
Okay.
Now,
this has to be done every day.
Yeah, every day.
So it's after the, let's say we get the mix we wanted at the 3rd batch or 4th batch, we do that then.
No, you do it as soon as they put the flaps on. When they put the flaps on, then
so after
you
the
take a
first
sample. Yes.
Then.
Yes. Okay. Because you want to answer for them. You have to tell them if they can go quicker or slower. Right? You need that answer as quickly as possible.
Exactly.
And it takes some time, right? So you do 2 minutes, then you do 5 minutes. So you wait 5 minutes in total, and then you do the shear vane. This bucket.
Total or
5
after
minutes.
the 2?
5 minutes in total. Good question. Yeah. Then because you're testing a different material, a different sample every time. You're not testing the same place, right? So you do 5, then you do 10, you do 20 minutes, you do 40 minutes, you do 60
stopwatch
minutes.
is better. Maybe.
Yeah.
To see.
I just do it on my phone. I just have a stopwatch that goes.
Yeah.
And then after 60 minutes, so you start at the first reading now, right? 60 minutes later, you have the last reading.
Okay.
You got me?
So after 1 hour, they can continue on the second line.
No. You let them continue. As soon as you have a good idea of how far you are compared to sort of my material and your previous day experience, right? Then you can tell them, okay, you can go quicker than yesterday or you have to go slower than yesterday.
Okay.
And that's for you to decide. But this tool gives you an idea of how quickly they can go. Okay, so you want to select the mix here. So we will do it for mix 1. If your data is in mix 2, then you select there from the drop down box. There, you can select mix 2. Okay, but for us, we want to do mix 1. Then you go here. This is the things that you can play with. Okay, so height of the layer, 25. You will start with 25, right? On a big building, you might want to go to 40 mil. Then you have to change that to 40 mil layer height.
Okay.
50 mil, that's kind of standard, right? Print path length, that's how long the print path is. You can get it from the slicer,
Okay.
right? And then here you can set your speed, the print speed. But that's not, those parameters are not the important ones. It's actually the layer time that's the important one, right?
Okay.
So what I did, I just set those two values so that I have here layer time. You see minimum layer time, that value.
So you don't choose this, you choose these to
Exactly.
get this. Okay.
Exactly.
Okay.
And then let's say they are printing now at 5 minutes. Then you aim for, let's say, 4 minutes, right? And you see the layer time here. The last one, the strength correlation factor, that you have to read off this table. So you go to the aspect ratio 0.5, so you go to this table, aspect ratio 0.5, go up to the line, the solid line, solid, yeah, and then you go over and you see it's 1.4. And the aspect ratio depends on your filament, your layer dimensions.
Okay. So
Okay.
so
Everything in yellow you have to change.
You have to change.
That's the rule.
Okay, and how do I choose the strength correlation factor?
Exactly. From the aspect ratio, what's the aspect ratio?
It's 0.5.
Okay,
But
go to the table.
It is 0.5. Ah, okay. It's always 0.5?
No, it will change if you change this to
Change the
30.
layers.
The aspect ratio, it's the aspect ratio of the layer, so how high to how wide is it?
Okay.
Right? And then you will get an aspect ratio here that calculates it for you automatically, and then you read off the strength correlation.
Okay, then I come and put it in here.
Exactly.
Okay.
Okay. Now,
Nice.
then you scroll down. You see for 4 minute layer time. you go to this green one. The green one, that's your answer, the top one.
Okay.
This means that you can print up to 1.3 meters with this material without having it fail.
Okay.
In plastic collapse. So this is not buckling. This is not it falling over. It means that that bottom layer that you just printed from your sample,
Can't carry on.
it can carry for 1.8 meters.
Cool.
According to this model. This is just a model. It's just mathematics, right?
Yeah.
It's not necessarily what goes on there, but it's a better estimation that we just guess.
Cool.
Okay? What I want you to do is not aim for a height. Aim for that it's into infinity. Okay? So what you'll do, for instance, you would say instead of getting 1.3, aim for having it negative. If that value is negative, it means that if negative, it says here, will not fail at any height.
Okay.
So that means this material is so strong that as this layer height, you can print to the moon. You can go to the moon. It's not going to fail. Okay. So what you do then, you say, okay, this one, it will fail at 1.3 meters. So I have to go a little bit slower.
Okay.
Right? So give it a little bit more time.